Welcome to the deep dive. Today, we're embarking on a journey, really, to explore a topic that's, it's touching nearly every aspect of our lives, artificial intelligence. We've gathered a whole stack of sources you shared with us, and we're going to try and pull out the most important nuggets of knowledge and insight. Our mission, basically, is to give you a shortcut, a way to get truly well-informed about AI's current impact. We're focusing on 5 key areas where AI is really making waves: perception, representation and reasoning, learning, natural interaction, and societal impact. We've uncovered some pretty fascinating, maybe even surprising facts. So yeah, let's dive in. Perception. Let's think about how we humans experience the world. Our 5 senses: touch, sight, hearing, smell, taste. These are our inputs, right? Coming through our eyes, ears, nose, and so on. And then we have outputs too, like speech, writing, facial expressions, even just body language. Now, what's really interesting here is how AI systems are starting to, catch up. And in some cases, maybe even go beyond our own abilities, take speech and hearing. Remember those early text-to-speech voices? Super robotic.
Oh yeah, clunky.
Totally. But now, AI-generated speech can sound incredibly human.
Yeah.
Sometimes it's hard to tell the difference. And hearing, speech to text is everywhere now. Think about interactive systems like Alexa or Siri. They understand you pretty well.
And it's not just about matching us. Look at smell. Humans have about, 6 million olfactory receptors? A dog can have up to 300 million. They're way better sniffers.
Right.
But now there's this new neuromorphic AI, kind of mimics how our nerve cells work. It uses chemical sensors. And when they're exposed to a scent like, say, methane or ammonia, they generate an electrical voltage readout. The AI learns to recognize these different scents based on their unique electrical signature.
Yeah.
It essentially remembers the smell's electrical fingerprint.
Wow, okay.
It's still early days, but the potential is huge.
Yeah.
Imagine detecting tiny gas leaks, or even, recognizing biomarkers for diseases just by scent.
That's amazing. And what about taste? That seems like a tricky one for AI. I read about a study, Technical University of Denmark, University of Copenhagen, Caltech. They were enhancing AI with taste. Although I think in that specific study, humans were still doing the actual tasting.
Huh, yeah, imagine that job. But IBM has something called HyperCase. It's a chemical sensing tool.
Okay.
It basically has this array of sensors, and they determine a liquid's chemical fingerprint, like all the different chemical components. That data gets sent to a server, and a machine learning model compares that fingerprint against a whole database of known liquids, so it can tell you what it is.
So less about does it taste good and more what is this chemically?
Exactly. Think quality control for drinks, or identifying unknown liquids quickly. Very practical.
Right. Then there's sight. AI vision systems are everywhere now, facial recognition, analyzing images, and they're absolutely critical for things like self-driving cars, right? Identifying other vehicles, people, lane markings.
Couldn't do it without them. And touch is the next logical step, really, especially in robotics. We've had robots in car factories for ages doing heavy lifting, but handling delicate stuff or oddly shaped objects, that needs a sensitive touch.
Like picking up an egg without breaking it.
Precisely. So Meta has developed something called Meta Digit Plexus. It's basically a standardized platform for tactile sensing hands. It gives you the hardware and software together so you can integrate these touch-sensitive capabilities onto a robot hand much more easily. Think manufacturing beyond cars, like assembling electronics or even handling food.
So when you pull it all together, AI isn't just mimicking our senses. It feels like it's, potentially surpassing them in some way, extending what's possible to perceive.
That's a good way to put it. New dimensions of perception.
Okay, so once AI perceives something, it needs to make sense of it. And that brings us to representation and reasoning. This is all about how computers manage information, how they alter it to solve problems or draw conclusions.
Yeah, exactly. Representation is step 1. How do you turn information, sights, sounds, data into something a computer can actually work with? That could be binary data, mathematical models, symbolic logic, lots of ways. But choosing the right way to represent the information for a specific task, that's absolutely crucial. It dictates how well the system can even tackle the problem.
Get the representation wrong and you're stuck from the start.
Pretty much. And then comes reasoning. That's the process of using that represented data to arrive at conclusions, make decisions, make choices. There are different flavors of reasoning: inductive, like spotting patterns; deductive, applying known rules; abductive, finding the best explanation. Often, AI combines these. But, the quality of the reasoning, it totally depends on the quality of the data it has and the cleverness of the algorithms using it. Garbage in, garbage out, still applies.
And a really common example where you see both of these representation and reasoning in action is, well, all those AI chatbots we use now. You ask a question in plain English, it gives you an answer back in plain English. But underneath, there's this huge complex system representing your question, reasoning about it, finding information, and then representing the answer back to you. The whole point is to hide that complexity, make it feel seamless.
Right. It's a very sophisticated process hidden behind that simple text box.
Okay, moving on to learning. This is a big one. We often hear about machine learning. What does that actually mean in this context?
Machine learning is basically the ability for computers to learn from data. They get better at a task over time without you explicitly programming every single rule.
How does that work?
Well, it usually involves creating algorithms and models that are designed to spot patterns in data. You train these models on large sets of examples. As the model sees more data, it refines itself, gets more accurate in its predictions or decisions. It's like it's learning from experience, but the experience is data. And there isn't just one way AI learns, there are different approaches. For example, reinforcement learning, or RL. Here, you have an agent, the AI, that learns by doing things in an environment. It gets feedback like rewards for good actions, penalties for bad ones. The goal is for the AI to figure out the best strategy or policy to maximize its total reward over time. It's essentially learning through trial and error.
Like training a pet with treats.
Kind of, yeah. Then you have deep learning. These are models with multiple layers, often called neural networks, because they're loosely inspired by the brain. These layers allow the model to learn representations of data at different levels of abstraction. So, for an image, the early layers might learn to recognize simple edges or textures. Deeper layers combine those features to recognize more complex shapes, and even deeper layers might recognize objects like a cat or a car. It builds up complexity.
Got it, like seeing the details first, then the bigger picture.
Exactly. And another major type is supervised learning. This is probably the most common one you hear about. Here, you train the algorithm on a data set that's already been labeled with the correct answers. So you show lots of pictures of cats labeled cat and pictures of dogs labeled dog.
Ah, so you give it the answers to learn from.
Right. The model learns the relationship between the input data, the image, and the output label, cat. Then, when you show it a new, unlabeled picture, it can predict whether it's a cat or a dog based on what it learned. Your email spam filter probably uses this.
Okay, so different ways of learning for different kinds of problems. Reinforcement for finding strategies. Deep learning for complex patterns. Supervised for making predictions based on labeled examples.
That's a good summary. Each has its strengths depending on the task and the data available.
All right, let's talk about natural interaction. One of the big goals in AI is making interacting with computers feel less computery, more human. You know, like when you talk to Siri or Alexa, it feels pretty natural sometimes.
It really does. The progress has been huge. But replicating true human interaction, that's still a massive challenge. Human communication is just so incredibly complex, so nuanced. Think about sarcasm, tone of voice, facial expressions, body language. AI is still struggling to grasp all of that subtlety. We convey so much more than just the literal words.
Yeah, that makes sense. And there's another complication, isn't there? Language itself changes.
Absolutely.
New words pop up all the time. Slang evolves. Old words fade away. Even the meaning or the way we use existing words can shift. So any AI trying to interact naturally needs to keep learning, keep updating. It needs retraining just to keep up with how we change our language. It's not a static target.
It's constantly evolving.
So it really makes you think, what does it really mean for an AI to understand us? It's got to be more than just processing words, right? Given all these layers.
That's a deep question, yeah.
Okay, finally, let's shift to something really critical, societal impact. As AI gets woven more and more into our daily lives, there are some pretty significant concerns and ethical questions popping up.
There really are, and they're crucial to address. One big area is transparency and trust. If we're going to rely on AI systems for important decisions, we need to be able to understand how they reach those decisions. We need transparency to build trust.
Otherwise, it's just a black box making calls.
Exactly, which leads to the black box problem. Some complex AI models, especially in deep learning, are notoriously difficult to interpret. Their internal workings are so complex, even the creators might not fully understand every step. This makes it hard to debug when things go wrong, or even harder to assign responsibility if an AI causes harm. Then there's the fundamental issue of aligning AI with human values. How do we ensure these powerful systems are developed and used in ways that are ethical, fair, and beneficial to humanity?
Yeah.
That's a huge ongoing discussion.
And a major part of that is bias and discrimination.
Yes, a very serious concern. AI systems learn from data. If the data they're trained on reflects existing societal biases, and most large data sets do, unfortunately, the AI can end up perpetuating or even amplifying those biases.
So biased data leads to biased AI outcomes.
Precisely. You see potential problems in areas like hiring, loan applications, even facial recognition systems having different accuracy rates for different demographic groups. It's a technical challenge rooted in societal issues.
And beyond those.
Well, there are broader risks, too. Things like privacy concerns, as AI systems often require vast amounts of data, the potential for misuse, think deepfakes, misinformation generated at scale, and of course the impact on jobs and the economy. Automation driven by AI could displace workers, requiring significant societal adjustments.
Which is why we're starting to hear more about things like ethical audits for AI systems trying to evaluate these risks.
Exactly. There's a growing demand to assess AI systems against ethical standards and guidelines before they're widely deployed.
But I guess the challenge there is, who defines those ethical standards? That seems like a huge debate in itself.
It absolutely is. There's no single, universally agreed upon set of AI ethics. Different cultures, different organizations, different people have varying perspectives. Implementing meaningful ethical oversight is really complex.
Yeah. This whole ethical dimension feels incredibly important. It's not just about what AI can do, but what it should do, and how we manage its integration into society.
It's fundamental for shaping the future responsibly.
So that wraps up our deep dive for today. We've covered a lot of ground, from AI starting to perceive the world in new ways to how it represents information, reasons, and learns. We touched on the quest for more natural interaction and landed on these really vital discussions around societal impact and ethics.
And maybe a final thought to leave you with. As these AI systems keep evolving, learning from all this data, adapting to our world, what's our role? Not just in defining the rules, the ethical frameworks, but in actively shaping how AI develops and how it gets woven into the fabric of our society. Something to mull over.
Until next time, keep exploring, keep questioning, and keep diving deep.